Lesson 17, subscriptive variables and angle relationships. The first thing we're going to talk about is a subscriptive variable. A subscriptive variable shows representation. It's used to represent something. We're going to look at a couple examples of these here in just a moment. They're used to classify things, to represent them in different categories. These are found mostly in word problems. Today we're just looking at equations with subscriptive variables, but in a few lessons we're going to be actually looking at word problems and pulling out our own equations with subscriptive variables and solving them. I would not recommend solving a problem in subscriptive variables. I would use each subscript to represent something else, and we're going to look at this in just a second. An example of a problem like this. We've got n sub n plus n sub d equals 40, and 5n sub n plus 10n sub d equals 250. Now, when we're talking subscriptive variables, it is a number or a letter that is smaller than the original number or letter. For example, n sub n. The lowercase n is the subscript to the big N. N sub d. The d is the subscript to the n. Okay, so that's when we say n sub n. That's an n with a subscript of n. N sub d. That's an n with a subscript of d. Alright, so we've got n sub n plus n sub d, and then 5n sub n plus 10n sub d. Now, these are representing what? If you're looking at a problem, you've got n and d, and if we look in the second equation, we've got 5n and 10d. Hopefully this brings to your mind money. Okay, n is nickels, d is dimes. 5 is how much a nickel is worth, 10 is how much a dime is worth. Alright, so n sub n represents the number of nickels. N sub d represents the number of dimes. Instead of solving this with a bunch of superscripted and subscripted variables, we're going to simplify this. Now you can do it with subscripted variables, but it's going to complicate things. So simplify, simplify, simplify. Instead of having the number of nickels plus the number of dimes equals 40, I'm just going to have nickels plus dimes equals 40. And instead of having 5 times the number of nickels plus 10 times the number of dimes, I'm just going to have 5 nickels plus 10 dimes equals 250. Okay, this way I'm only dealing with one variable instead of the subscripts. Alright, so subscripts are just used to show representation. I would recommend, encourage, tell you that you need to go ahead and just simplify to one variable. Alright, then we've got 2 equations with 2 unknowns, and you would solve either by substitution or elimination. What I want you to do is go ahead and solve this one on your own. Hit the pause button if you need to, and then when you're ready to hit play, we're going to look at another example. Alright, the next example we're going to look at is a little more complicated. So let's write down the problem, and then we're actually going to substitute things in. We have r sub m t sub m plus r sub w t sub w equals 260. Right? And then we have r sub m equals 40, r sub w equals 60, t sub m plus t sub w equals 5. Alright, we have all these variables with subscripts in them. We're going to see a problem very similar to this, probably closer to Christmas, if not right after Christmas, called a rate times time problem. Alright, R stands for rate, T stands for time. The subscripts are the specific people that they're dealing with. So we have the rate of Molly, the time of Molly. The rate of Wilma, the time of Wilma, okay? You can use whatever names you want. But that's what these are used for. I would recommend using different variables. Now, the nice thing about this is that r sub m is given to us and r sub w is given to us. So we can solve for these in, we can plug them into our equation. So instead of r sub m t sub m, we have 40 t sub m plus 60 t sub w. And instead of m and w, t sub m, t sub w, I'm just going to call them m and w. So we have 40m plus 60, because r sub w equals 60, w equals 260. So we've used substitution and substituted these quantities into this equation. And then we've used just w and just m as our variables. All right, so there's one equation, 40m plus 60w equals 260. Again, I'm going to use just m and w. So our second equation is m plus w equals 5. So we have m plus w equals 5. Now it's set up nicely as a substitution elimination problem. So again, I'm going to go ahead and have you pause the video and solve, and hit play when you're ready to move on. All right, the next thing that we're going to talk about is angle relationship problem. These are not anything new. Hopefully this is a nice, easy review problem. Keep in mind the different angle relationships. Supplementary angles are equal to 180 degrees. Complementary angles are equal to 90 degrees. Okay, know your exterior and interior corresponding and alternating angles. All right, so using information that we have already learned, I want you to go ahead and solve for x and y in this example, and we are going to check it when we come back into class. Once you've solved, that is it for the note.